Now let's talk about Roman numeral 3, limiting reactant problems. And we'll start with the question, what is a limiting reactant? And a limiting reactant, my abbreviation is capital L, capital R, and it's also called a limiting reagent, though I will call it a limiting reactant. A limiting reactant is the reactant that you run out of first. It is the reactant that you run out of first, and at the end of the reaction there is 0 left over. I guess that should be a capital T. So at the end of the reaction, there is 0 or 0 left over of the limiting reactant. And then something for your notes that is important, though it may not make sense yet, because we still have layers of the chemistry onion to get through. But the point I want to make here is you can use the grams of limiting reactant to do calculations. You can use the grams of limiting reactant, and I'm just going to write out LR, to do calculations. Period. That one is actually a sentence. Okay, for the excess reactants, so for the excess reactant, there is some left over. Though some is used up, or reacted, and you cannot use the grams of the excess reactant to do calculations. You cannot use the grams of excess reactant to do calculations after determining it's the excess reactant. And hopefully you'll see what I mean. We will do a calculation just to prove whether it's excess or limiting. And after that, we won't use that number in the type of calculations we're used to doing. Okay, so that's sort of a little bit of what is the limiting and what is the excess reactant. Now let's do a limiting reactant analogy to sandwiches. And the question is, how many sandwiches can we make if we have the bread and the cheese here? And so let's write with the bread and cheese on this page. And that means we have 12 slices of bread and we have 12 slices of cheese. And what you might imagine is the number of sandwiches you can make depends on what is the quote-unquote chemical reaction for your cheese sandwich. And I know the formula is, well, let's see how it works. So for my sandwiches, I like two pieces of bread, and I like 3 pieces of cheese, and probably some mayo, tomato, lettuce, and some chicken too, hopefully just freshly grilled on my grill. And the only thing really that's I need for this analogy is that these two numbers are different, and they are. Now, if you were doing this and you're like, well, I got 12 slices of bread and I got 12 slices of cheese, it takes more cheese, so that's going to be what I'm going to run out of first. And just to drive home the point, let's circle each sandwich at a time. So I'm going to have 3 cheeses and 2 slices of bread. And I'm going to have 3 more cheeses for my second sandwich and 2 more slices of bread. And we can continue on. And what we can show is that we run out of cheese first. And so in this analogy, let me see, yes, just by circling things, or just without even doing any chemistry or calculations really, we can find out just by circling things that we can make 4 sandwiches. And then what I would say is cheese is our limiting reactant. Because we run out of cheese. And bread is our excess reactant. And you can see very clearly that we have 4 pieces of bread left over. And we didn't even do any calculations. But what I'd like to do on the next page is I'd like to put this in the form of how we're going to do it when we do the chemistry part. Well, we'll keep this in mind, so I'll keep this close. Okay, so here's one thought process for solving this problem. It says, how many sandwiches can we make if bread is the limiting reactant? And then we're going to ask the same question for cheese, and then we're going to ask how many sandwiches can we really make? So if bread is the limiting reactant, and we know we have 12 bread, and we know that in one sandwich there is, let's see, one sandwich, 2 bread in one sandwich. Then we can make 6 sandwiches if bread is the limiting reactant. And that means we have plenty of cheese, which clearly we don't. Now, if we have 12 cheese, and it takes, oh, yeah, that's right. And it takes 3 cheese to make one sandwich, then we can make 4 sandwiches if cheese is the limiting reactant. And then the question becomes, how many sandwiches can we really make? We worked the example on the previous page. And what I want to say here, though, is when you do this chemistry-wise, it is always the smaller amount of product that you can make. It's never the sum of them. It's always the smaller amount. And once you do this right here, and this calculation up here, we will never use the 12 bread in a reaction, in a calculation again, like this, where we convert it into something else using unit conversions. We will use the 12 cheese though, because the 12 cheese are actually used up. And this is the starting point for all other calculations that we're going to do. So that is the thought process for thinking about limiting sandwiches in terms of sandwiches. We still have some more to do. Question, what is the limiting reactant? The limiting reactant, oh, let me answer this question. How many sandwiches can we really make? I'm going to turn that into a colon and say 4 sandwiches. Then, what is the limiting reactant? Cheese. And then how much of the excess reactant is left over? Well, we know how much just by circling things on 2 pages ago, but let's calculate it. So the calculation for the excess reactant starts with the limiting reactant. And we have 12 cheese. And we know that in one sandwich, there are 3 cheese. And that one sandwich also contains 2 bread. And so these are like the coefficients in the balanced reaction for a sandwich. And what this says is let's do this. 12 divided by 3 times 2, I get 8. 8 bread are used up to make 4 sandwiches. So if we start with 12 bread, and we react or use up 8 bread, we end up with 4 bread left over. And that should be capital B, I guess, but hopefully you get the point. There are 4 bread left over. And again, if we go back 2 slides, we will see that our circling ended up with 4 pieces of bread left over as well. And in the bread and cheese and sandwich case, it may be more obvious, especially when we circle things, but we're going to have to do it chemistry-wise. And we will start with the limiting reactant, and we will be able to do a calculation to show how much is used up of the excess reactant and how much is left over.